My name is Kelly Elder. I'm a research hydrologist for the U.S. Forest Service Rocky Mountain Research Station. We're here today on Berthoud Pass on U.S. Highway 40 in Colorado. We're at about 11,000 feet above sea level in a winter snowpack. We will be doing a training video today, and I will demonstrate techniques that will be used in the NASA SnowEx program over the next few years. These techniques are specific to the NASA program, but they're applicable in a wide variety of settings, and they may be used for other environmental science applications, other hydrology applications where snow pit information is needed. I do want to emphasize that this is not an avalanche training video, and I will not demonstrate any methods of checking snowpack stability or instability. This is strictly for hydrology and snowpack characterization for hydrologic or remote sensing or energy balance studies. I'll be demonstrating some techniques for measuring things in the snowpack. I do want you to focus on safety. Safety is number one out here. No data is worth collecting for any reason if you have an injury or accident or a fatality. So early in the day, late in the day, late in the week, when you're tired, to keep safety in mind at all times. We'll be following general safety protocols in all of our NASA studies. If you have any questions about those protocols, talk to your local supervisor or group leader, or contact a NASA safety supervisor. Safety is number one out here. Data quality is number two priority after safety. The data quality is critical here. If you can't take good measurements, you shouldn't be taking measurements. If you're not committed to high data quality, then it's not productive to collect the data. It's basically the garbage in, garbage out philosophy. And if you collect data that's compromised in some way, it'll get used in a compromised science application. These are legacy data sets that we collect out here in the field. It costs a lot of money and a lot of time, a lot of effort. Your time's worth a lot of money, and we don't want to compromise that in any way. So don't collect compromised data. If you have a data element that you collect that you have in question, recollect it. There's plenty of opportunity to do things right out here. We do want to be efficient and get as much data as possible, but not at the expense of high data quality. Some of the data that we collected in the 2000 through 2004 CLPX, Cold Land Processes experiment, is still being used for relevant science today, decades later. The same will be true with these data that you're going to collect in this experiment. So take the time to do this well. It'll benefit you, and it'll be part of your legacy as well, and society as a whole. Have a plan in your data collection and follow it. Get a routine. When you approach the site and start digging your pit, go through the same steps every time. That'll allow you to be efficient and allow you to collect more data. There's no point in rushing and compromising the data, but there's no point in collecting one really, really carefully done pit in a whole day where you get a really low sample size and we can't do much with the data. We have to run this balance between data production and data quality. So try and optimize that, be efficient, collect high quality data, but one pit doesn't do us much good and a whole bunch of sloppy data doesn't do us much good. So really focus on your program, be efficient in the pits, collect your data well, and collect as much as possible within reason. If you're part of this NASA SnowEx program, you should follow our basic protocols as demonstrated in this video. You're welcome to deviate from that a little bit. You'll have methods, if you're an experienced snowpack profiler or data collector, that work better for you, and you may benefit some from adopting some of the techniques shown in here. We don't want you to change the basic protocol. We don't want to be comparing apples to oranges when we do the analysis, and these data are used for science in the long run. We do want you to collect things by the same methodology. The sequence that you do them is not critical. And there is some variation, and you'll be able to tell where you can deviate from this protocol a little bit. But to be consistent in our data and have high quality data, we want everybody on the same page doing the same thing. So try and follow these protocols as we outline them today as close as possible. We won't show everything that we're going to do in these pits in this video. For instance, we'll be doing liquid water or liquid moisture in the snowpack as well. I don't have any of those tools with me today. You'll be trained on site by your local program coordinator or program leader to make those measurements. I won't go through some of the other site details that we will do that will vary site by site, but you'll be trained on those separately. I'm going to focus on the snowpack fundamentals in this video today. We have pre-formatted data books that we use in this experiment, and those are specific to the applications and the science questions that we're asking on a year-to-year basis for this program. Please be careful to fill out every blank in the book. The reason we have pre-formatted books is that if there's a space there, it should be filled out. And if there isn't a space there, if you're working on a blank sheet, trying to remember what you should be recording, inevitably we forget to fill out some of the data or collect some of the data. When you leave the site, that book should be filled completely. If there's a box that isn't appropriate, you should fill it with an NA or a 0 if the 0 is actually a 0 measurement. A 0 is an actual number, and 0 in something doesn't mean you didn't measure it. It means the value there is 0. So if you fill out a blank and it's a blank that you have not filled out for some reason, acknowledge that with a NA, not applicable. Okay, so every blank should be filled out, except for the ones that are long lists of snow depth measurements or something where you've run out of snow depth. But every header blank, every metadata blank, all those blanks should be filled out top to bottom on every sheet before you leave the site. Please be very careful in your writing. One of the problems that we have on these experiments is that people have different handwriting skills. Sometimes it's hard to tell a 1 from a 9, from a 4, from a 7. And a year later, when somebody's looking at those data, or even a week later, and trying to decipher your handwriting, this can really compromise data. There's a data point. There's a big difference between 90 centimeters deep and 10 centimeters deep if your 1s and 9s look alike. So really focus on that. If you're a sloppy handwriter like I am, take a little bit of extra time and make sure that those are going to be readable, even if they get smudged or compromised in the field. All the books are right on the rain paper so that they will collect data or allow you to record collected data fairly well, even in adverse conditions. The notes sections of the data books are particularly important. You really can't collect, or you can't record too much in the notes sections. Those are the places that you can write down small anomalies, things that were weird about the site, things that were interesting about the site, problems you had, or special observations that don't fit in a normal box. There's several places you can do that. You can write in the margins. You can record that extra information anywhere you like if you can't fit it all in the note sections. These are often the most important parts of the data section, so don't hesitate to write a lot of relevant data in the note portions of the books. The methods that we're going to demonstrate today here are based on decades of research and decades of development. The tools have been used for decades. They're well tested. There are a number of tools that are used for these kind of measurements worldwide, and some of them differ from the ones we're going to show you today. We're using these because they've proven to be the best to our knowledge and our applications in North America and in other parts of the world as well. You're free to use your own tools on your own studies, but we're going to give you tools to use on this study, and we want you to use the same tools again so that we are comparing apples to apples at the end of this study. Have fun. This is supposed to be interesting to you too. The snowpack tells you an awful lot of cool stuff. When you're digging the snow pit, you'll feel things with your feet as you're digging it. You'll feel things with your shovel. Once you get out your hand lens, you'll see stuff at a different scale, at the micro scale. Your probe will tell you information. You'll be doing specific tests on the snowpack. The snowpack is there exposing itself with a little help from you, and it is begging to give you information. So be open, use all your senses, your eyes, your ears, everything you have, your hands, and collect data. There's a lot happening in these snowpacks, and it's fascinating. This is why we spend our lives doing this stuff.